On Wednesday, we did this paper, so everybody look at percent graphs. If you weren't here on Wednesday, you need to watch the video from Wednesday. So this is some matching with percent rates. So the first one, those were all increasing. So this is, you have a bank account, it earns interest, okay? Then it's all increasing and going up. And then our equations reflect that too. We have our starting amounts, which if you look back up here, starting amount, and then our rate. But the thing with percent increases is that we have that 100% plus whatever the increase is. 100% is what you already have. So if I already have $600 in my account, then 100% is that $600. And then I'm increasing that amount by a certain interest rate. So that's why I add the 5% to it to get the 1.05. And that's for, let's say C, 600 times 1.05x. So that's whenever you have an increase, you add 100% to it. Now, anytime you have a decrease or depreciation, then you're going to subtract from 100%. So on these, the car was being depreciated by 30%. So we have 100% is what our car is worth right now. And then it goes down. So we have to subtract the 30% from it. And that is why the rate is 0.7 or 0.70. Okay, we do need to answer number 10. So let's look at that. Are the above depreciating value graphs increasing or decreasing? And we already said it's decreasing. Over time, the value decreases. If the interest rate from the bank is 7%, which if you're earning 7%, that's awesome. That's a great interest rate. Right now, it's like what I get on my bank account is like 0.002% interest rate, which that's ridiculous, right? You don't earn much on a savings account. If the interest rate from bank is 7%, the exponential function to model the amount of money over time is 1.07x. Why is the multiplicative rate written as 1.07? So 1.07 represents 107%, right? If we convert it from decimal to percent. So what this means is that you increases from 100% to 107%. Because if you're earning money, you're going to add to 100%. So add 100% to your rate. That's why. You're going to add 100% to your rate. Okay, number 12, if the depreciation rate for a car is 25%, the exponential function to model the value of car over a time is 0.75 raised to the x. Why is the multiplicative rate 0.75? Subtract 25% from 100%. When the value decreases. So we take 100%, subtract 25%, and we get 75%. And then it's always written as a decimal, 0.75, because we move the decimal over 1, 2 spaces. So let's look at our digital interactive notebook now. We need to look at the growth and decay slide on slide 20. I'm going to zoom in on mine. So we stopped right here and we went to percent graphs on last class. So we are coming back to this to finish this slide. Identify the initial value, the growth factor and growth rate given the function f of x equals 9.25 times 1.04 raised to the x value. So our initial rate is 9.25. Our growth rate is 1.04. Growth factor, I mean. So what is the rate? 4%. Yep, 4%, which is also written as 0.04. I want you to write both of those in there. On your EOC, they use that a lot. They use your percentage. So you got to know what if it's increasing by adding 100% to whatever your rate is. And then decreasing, you're subtracting whatever your rate is from 100. Let's look at problems 2 and 3. The height of a mountain shrinks 0.5% each year. If the mountain is 15,560 feet tall, how tall will it be after 20 years? We can draw or write our function. So let's do f of x equals. To write the exponential function, we would write our initial rate times our rate raised to the x power. Or our initial value, our start. So 15,560 times, we need to do the rate. But the rate here, it says it shrinks 0.5%. So what does that mean whenever it shrinks? Is it an increase or a decrease? It's a decrease. So we need to write what our value is. So we have 100%, right? And we are subtracting 0.5 from that because each one is written as a percent. So it's 99.5%, but we need to write that as a decimal. So we move our decimal over 1, 2 places. So our rate is 0.995. And then raised to the x value. Do y'all remember how to do exponents on here?
Yes.
Command or control and the greater than symbol. Put your x there and then control greater than to bring it back down. That is our function because this is what we start with. The mountain is 15,560 feet tall. And then it's shrinking. So that means it's a decrease. So we subtract this from 100%. Then change it to a decimal. And now we want to know after 20 years how tall it would be. So how do we find out after 20 years how tall it'll be? Replace x with 20, exactly. So I'm going to do f of 20 equals 15,560 times 0.995 raised to the 20th power. So let's put that in the calculator. Everybody do this. so that you make sure you know how to do it. 15,560 times 0.995 raised to the 20th power. Push enter. So let's write our answer in words. Is that what y'all got?
I have an E64 at the end of mine.
Okay, so if you have that, you need to change your mode to normal. Is yours on normal or is that on? Oh. Did you put in the right?
Yes. Oh, yeah, that's what I did.
Okay, thank you. Yeah, you need that 0.995. Okay, is mine right now? That's right, though. Yeah.
Okay, now I got it.
You got it now? Okay, so we need to write our answer in words. So it says, how tall will it be after 20 years? So we should say, the mountain will be 14,000. Let's just round to the whole number. 14,076 feet after 20 years. Okay, next problem. Population of a small town grows 6% each year. If the population was 3,525 years ago, what is the population now? So what is our starting amount? 3,500. And then what is our rate? 6% each year. So what rate am I going to use on here? It's more than, right? It's increasing. So how do we find what rate to use in our function? We add 100% to it because 100% is what they have, and then they are increasing by 6%. So we do 100 plus 6%, which gives 106%, and we write that as a decimal as 1.06 raised to the x value. We want to know what the population is now, 25 years later. So how do we find the population now? Replace x with 25. So go ahead and put that in your calculator and write your answer as a word problem or a word answer. All right, let's see how you did. Is this what you got? Okay, we're going to round it to the nearest person because it's population. It's talking about how many people. So that would be the population is 15,022 because of rounding. Now, Okay, one last thing I need y'all to do is copy and paste these slides that are on Google Classroom. It says add these slides to your Unit 8. So click right here on Google Classroom. Copy these 2 slides and insert it at the end of your digital interactive notebook. And there is one slide that says blank data or something like that. Just delete that. And you should only have 24 slides now. At the end, yes. And then the last thing I want to talk about real quick is we're going to do domain and range next class. So growth or decay. Let's just look at this one real quick. If the graph is going downward, that is called decay. It's kind of like if something is decaying, it's rotting away. I hate the word decay though. It's gross. So we'll put exponential decay. Decline, decay. So if it's going down, it's a decay. And the number, the percent rate, is going to be between 0. So I'm going to, I need to change the color after that. Let's see. Change it to black. Then put rate is between 0 and 1. You're going to have to change your text color to be black to be able to see it. And then this other one I'm going to change to black also. So the purple one is a decay. It's going downhill, and the rate is between 0 and 1. You can't have a negative rate. You would just have a rate that is between 0 and 1. And then the other one, the green one, is an uphill slope. So this is called exponential growth. And that is when the rate is greater than 1. All right, so that is all I have for you today. You have no other homework except for finishing the EOC review.